who are joining new, you will get the recording session later. Okay. Let me know if my screen is visible to you.
Yeah, visible.
Okay. Great. So what we discussed yesterday, that is a part of your traditional server, virtual machines, disadvantage and container I already discussed, right? Now, point is that uh, just I will review container for you only because during the container sessions, um, just we disconnect our session was terminated, right? So regarding the container, as it you already told it is a application package, right? So that is the things that we will write here for discuss yesterday. So here a container is an application that has been packaged with all the files. Files means that you need that file to generate your container. Config the configuration files, leave library and the dependency. In the dependency also it has its own operating system. That may be very little part of that because the operating system, the uses container use from the host operating system. That is Linux. Let me show you again that part. See, that we draw that. Basically, this is your base operating system, and as per the industry trend or industry wants, so everyone use the Linux. Okay, so container like the Gmail application running with this container. So with the maximum weight, 95% of the weight will take from the your host operating, right? And 5% that I'm talking about, say 5% will take from the will have within the dependency. So these are the basically a software package we can consider files, config, libraries, and the dependency. Apart from the operating system dependency, I'm having some other files. Basically, these files help to plug in the automation part. These are the not exactly I will say the container part, containerization concept, but in the future, like the in the cluster when the your pod will run, when the Kubernetes cluster, when the OpenShift cluster come into the picture, so it helps to plug in with some other third-party tools. Okay, so later we can see that. I'm not going deep into it now. Container is lightweight, you know. Why? Could you please tell me? Anyone?
Yes, containers lightweight because it don't have.
দিয়েছে না ও বদমাসটা নিয়ে গেছে বন্ধুদের ওই
So,
It may be the OS is not stored in a container.
right. Thank you. So basically, it has the only applications part, right? Does not have. basis. In technical way, if we say container does not have OS, that is wrong. I repeat, in technical way, if we say container does not have the OS, that is wrong. It has very little part, very little part. But we can write that whenever if anyone checks in an interview what you have inside container. So must you have to tell that yeah, it has its own OS, but that is very little part. We can negligible because it does not take much space. Like it is size in the KB, even not in MB. So please note that part. Maybe I write here does not have OS, but technically it is wrong. Okay, guys. Yes, no, please respond.
Yes, yes.
Yeah, container have many advantages that yesterday we were discussing, right? It has many advantages. But I'm not writing all the advantages. You know all those things. Uh, what I try to focus in the main point why the actually required. Okay. Apart from that, we have many points here. I'm directly going to the disadvantage that also require. Anyone tell me the disadvantage? 1 point, 2 point, anything. Just try to relate with the picture and tell me if you can remember yesterday call.
If we can move the any image to another user, then it should be same OS in the another sorry in the
Okay, I understood your point. Great, Himanshu, great. That is basically the way things goes here because uh, whole the industry when we talk about the containerizations, may you later can observe everything based on the Linux operating system. For example purpose, we can take some other operating system just that I showed yesterday, but in practical that is not the scenario. Still, that is also that is also a disadvantage if we are developing some container in the Windows environment based on the Windows operating system, and later we transfer to the some others environment like having the Linux OS, right? So it will not work. That is your point, right?
yes, yes, yes,
Right. That is okay. I can consider that.
yes,
We can
yes,
consider
yes.
that. Main big disadvantage is that the big disadvantage if the server with crashes.
Okay, there is no restore and backup
Then
option.
I think restore
all
is there. We have replica, right? Right, Nandan?
then all your container will down. Here, Render, tell me.
Someone said that container don't have any storage means there in the map. So, but so I want to know. So container have the replica. We have replicas. So if any container goes down, then replica came up with new one, right? So they have
Yeah.
all the data whatever we have in earlier containers.
See, Rajendra, this is not actually the concept. container does not have any replica. We create replica through the pod. Okay. Yeah, that is the thing that we can get our same applications in our cluster. That is correct.
Mm-hmm.
Suppose one container down in a particular way, if I say one container down, one, so that means
Mm-hmm.
that application goes down. Maybe Jibal server that goes down. So Kubernetes
Yeah,
cluster
but
will help.
uh,
Yeah, Kubernetes
mhm.
cluster help to replace that container with a fresh and healthy container. That
With
container will
for
application run your application. But still we not that place. We not that place. But yeah, and that will happen through your pod in the cluster, in your Kubernetes cluster. I'm just writing the point that Himanshu just tell.
Varana.
With not talking, please mute yourself.
Also calls container having more complexity to manage
To manage what?
operation in production environment. Like Kubernetes also having lots of complexity.
What complexity?
Where are
Means
the
like container orchestration tool,
Hmm.
like mm, manage especially large scale environment
Hmm.
such as Kubernetes tools.
Hmm.
So that is also important. Also some networking complexity also there if multiple hosts are involved in this cluster, like in a big cluster.
See, Shomit. Yeah. So whenever you have the component resource increase anywhere, not only your uh, Kubernetes cluster, so anywhere there are multiple things come into the picture, na? So gradually the complexity increase, and due to remove that complexity, due to uh, due to the high volume of your traffic, maybe some other resources. So of course there are some mechanism to solve the complexity, to remove the complexity, and other part of the uh, managing the cluster, configuration, deployment of the cluster. So many mechanisms there that we will discuss. That we will discuss. But if we don't have the Kubernetes, so we're not able to communicate the other containers, able to not able to run the applications where we have the multiple containers. Okay, so there are many dependencies. When I will come topic by topic, so you can understand the link.
Okay, got it, thank you.
In this point, anyone have any doubt? I want to clear before move. Okay,
No, it's good.
okay, great. Now, just try to tell me, as you have some idea now regarding the container and the virtual machines. What are the difference that we can highlight here? What are the different we can mention here?
Yes, container having a OS virtualization and virtual machine having a hardware virtual hardware sorry.
Yeah. Okay, I understood your point. Can you please analyze that for other guys here? Can you please analyze it? I'm just writing your points, huh? Meanwhile, you
Yes,
can
yes.
analyze it.
Software. Okay. In virtual machine hardware dependency.
Hmm. Next point. Anyone?
Container having lightweight weight and virtual VM having like
Okay.
heavy weight.
Okay.
Include.
Restoration timing during an outage.
Yes. That is basically any booting time at any reason when it takes a boot. So it takes time to off for the VM, right?
Yeah, that's what I want to say.
Anything? Just I want to show the picture so you can compute it.
Request hypervisor in VM.
Okay. Okay. Fine. This is our VM and this is our container. Now, seeing the picture, try to relate some points. Okay.
The
What?
virtual scaling capacity more high than VM. Like if in VM we are having less VM machines, but in
Hmm.
container you can get more virtual machine.
Okay. Both ways is there. As you saw, the base operating system Linux, it taking help, container taking help from that OS.
Yes.
And in terms of in case of virtualizations or VM, they have dedicated OS.
Dedicated hosting. Yes.
Guys, I'm sorry. Again, you have to join. Okay. I did not find any other way to do the media that I can do the sessions.
Let's share the link to join.
No, already links here. You can directly join again. See, uh, VM takes a lots of memory, a lot of. You can see there. I just mentioned there. VM consume a lot of disk spaces, lot of RAM, lot of CPU. So that point we can mention. Directly we can use this sentence also. We can use this sentence. Just I write down the flight point. Yeah. Now, I coming to the first point. Containers virtualizes the OS or software. Okay. Here, virtualization is hardware. Virtualization is a hardware level base that I want to discuss, and we'll finish soon. Now, you can see my screen now.
Yes.
Anyone? Okay.
Yes, yes.
Great, great. See what happening here in the virtualization scheme when we are creating the VM. When we are creating the VM, what happening here? This is our Dell server. This is our Dell server, and in the Dell server we have resources like the your vCCU, your spaces, memory, NIC card, etc. Right. With the help of the resources, hypervisor directly creating the VM. How? The hardware resources hypervisor mechanism converting in the virtual functions. So here in the like the VM1, it directly uses the hardware resources. It directly uses the hardware resources. The functionality of the hypervisor, I told yesterday, is converting the hardware resources and directly making a VM. That is virtual machine. But the hardware resources is creating the virtual functionality like the our CPU, our storage, spaces, memory. So all the resources converting in the VM. So we can consider it is directly uses the hardware resources. When we talk about container, when we talk about the container, in between we are using the container engine. Okay. So the container engine taking some courses, some code, okay, taking some code for your application. Suppose Gmail application we are running through container, this container. Here we have the config file. You can see these are our config file. What happening for the Gmail? They have created some code. They build up some code and they put inside the config file only for the Gmail. This config file will not work in the web server. Yes, that's right. Web server has its own config file. Also, we have a config file here, but that not same like the Gmail. So Gmail having the different config file, web server having the different config file. So based on that, just example, based on that, because we also have the libraries, we also have the dependency, few things common like the web. Inside the dependency, we have say 5% of the weight. It's require 100% weight operating system. 95% of the weight it's taking from the host operating system. That is our host part, right? That is base operating system, and it's just we are using in the host part. This is our host part directly on your server, directly on your server, top of just your server. This code server, maybe Dell or something, or maybe private cloud, maybe public cloud. So we have already cloudifications here. That's possible. You can see if we remove the code part, what we have? Private cloud, then we have public cloud. So already we have the cloudification. Already we converted the hardware part in the cloudification. Based on that, we are working. And because why we are calling it software package? Because these are the file. It come in a package, not a separate way. Okay. This package, suppose we have a cluster. This is our cluster. This is our cluster, right? In this cluster, we just create a container, and based on that container, we are running the Gmail application. You directly take this container and you can throw to other clusters. Like in this cluster, I can throw it. So it will work. Just try to understand my point. If I throw the container to this cluster, the next cluster, this is my red mark. This is cluster A. If we can consider this is cluster A, and this is cluster B. So if I throw the container of Gmail, that application Gmail running based on that container. In the B cluster, if we have a cluster ready, so Gmail container can run. We can run the Gmail application based on that container. That is the reason it is a virtualized software package. Like the point I write here, the point container virtualize the OS or software. Here, when I say OS, means it is a package, not only your OS part. Like the we consider this is the Linux. Not only that, we have a whole package that may be your dependency part, that may be your config file part, that may be your library part. So this is the reason it is directly on your hardware level with in terms of the virtual machine. And when we say the container, it is based on your package. You can consider or you can say this is package. Okay, that is quite good. That is right. Here in this point, any doubt? We'll move to next. We'll just move to next topic.
Yes, you can move.
Okay.
Next.
So in 1 minute, we our session, our Zoom will disconnect. So what I'm doing, I'm just stopping here, okay, and we will creating. We're joining with the link.